Hello everybody, today we're going to talk about solving linear inequalities. So a solution of an inequality in one variable is any value of that variable that makes the inequality true. Okay, most inequalities have thousands of infinite number of solutions. Okay, so how do we graph that? How do we solve that? Well, this is a very simple one. This one's already done. X is less than 2. So what we're going to do, we're going to go here, we're going to find 2 on our graph. We're going to put an open circle right here. It's open because 2 is not a solution to that. We want to show that. 2 is not less than 2, so 2 is not a solution. But anything right up to 2, 1.999999999 is a solution, but 2 isn't. So we're going to shade everything to the left here because these are the numbers that are less than 2. And so you can see there's an infinite number of solutions to this thing. Okay, and then we've got this one here. We got the inequality x is greater than or equal to -1. So what we're going to do this time, we're going to have a closed dot because -1 is a solution to this because -1 is greater than or equal to -1. And this time we're going to shade the right side because we want the numbers that are bigger than -1. Okay, so you got to remember, you're going to use an open dot for a less than or greater than sign and a closed dot for a less than or equal to or greater than or equal to sign. Okay, we're going to solve this inequality. You're going to treat this just exactly as if this was an equation. Okay, so we're going to take this. If this is an equation, an equal sign here, we would just add 8 to both sides. So 3y. We're going to leave our less than sign. It's going to be 18. And we're going to divide by 3. So y is going to be less than 6. Okay, so we're going to take 6, and we're going to go ahead and it's a less than, so we're going to put an open circle right here, and we want the less than sign, so we're going to want this side right there. So any number that's less than 6 will make this a true statement. Okay, so on this one, we've got 3x minus 2 is less than or equal to 5x minus 3. Okay, so we're going to treat this just like we would an equation. We're going to go ahead and subtract 3x from both sides because I like to keep my x's positive whenever I can. Don't forget that minus sign is attached to the 2. It should come down with the 2. I'm going to add 3 to both sides. Okay, so this is going to be 1 is less than or equal to 2x. And I'm going to divide by 2. And now I always like to have my variable on the left side, so I'm going to switch this sign around. X is greater than or equal to 1/2. Okay, so we're going to go over here. We'll put 1/2 right in the middle of this thing. I don't know, put some numbers on here like this. There we go. And then we'll go and we'll put our closed dot right here at 1/2. And we want to shade the greater than side, so we're going to go over here. Now, the only thing that's ever different about solving an inequality like this is if I ever multiply or divide by a negative number, I have to flip this sign over. Don't forget that. Okay? But only if you multiply or divide by a negative number. The rest of the time, it works exactly the same way as it does an equation. Okay, a compound inequality is a combination of two inequalities joined by an and or an or. So you got to satisfy two inequalities at the same time. So this one's already done. It's already solved. You can't do anything else to this. But my x's must be greater than or equal to 1, but less than or equal to 3. So what I'm going to do, I'm going to go put a closed dot here at 1 and a closed dot here at 3. And I'm going to shade the numbers that are more than 1, but less than 3. So it's going to be the ones between those two numbers. Okay, my other alternative is to do the or situation. This was the and, this is an or. Okay, these are two separate equations, and I just treat them separately. So I've got to be x is less than -2, so I'm going to put an open circle here at -2, and I'm going to shade the smaller numbers. Now, this is tricky. This one's greater than or equal to 1. I have to have a closed dot on this side and shade the bigger side. Okay, so remember, 1 is a solution to this. -2 is not. Okay? So it's just like that. Okay. So we'll take this equation, we'll just copy it over here. -4 is less than or equal to 2x is minus 6 is less than or equal to 12. Okay, how do you solve these? Well, you do it exactly the same way as you would solve an equation, except instead of doing things on 2 sides, I'm going to do it on 3. So on this, when I add 6 to solve for x, I got to add 6 here, but I got to also add 6 here. Okay, so this is going to be 2 is less than or equal to 2x, which is less than or equal to 18. Now I'm going to divide by 2, and remember I got to do it in all 3 places, so I got to do it here, here, and here. So I get 1 is less than or equal to x is less than or equal to 9. So I'm going to go ahead and put a closed dot at 1. I'm going to put a closed dot at 9. And I'm going to shade all the stuff in between there. All those numbers are solutions to this equation, or this inequality. Okay, here's the OR situation. What do you do with this? Well, we have 4x plus 3 is less than 7. 3x minus 8 is greater than 7. So what I need to do is I just need to solve these separately. So I'm going to go ahead and subtract 3 here. So 4x is less than 4. And I divide by 4, and x is less than 1. I'm going to come over here, open circle at 1, less than 1. Okay. I'm going to add 8 here. 3x is greater than 15. Divide by 3, x greater than 5. Okay, so I go greater than at 5, shade the numbers that are bigger. Piece of cake. Okay, you've added enough antifreeze to your car's cooling system to lower the freezing point to -35 degrees Celsius and raise the boiling point to 125 degrees Celsius. Now, normally, if you just have water in your radiator, that'd be 0 on this end. Or I'm sorry, it'd be 32 degrees Fahrenheit, but it'd be 0 Celsius. And it'd be 100 degrees Celsius on the boiling end. Okay, so you've expanded the range there a little bit. The coolant will remain liquid as long as the temperature C in degrees Celsius satisfies the inequality. -35 is less than C is less than 125. Write an inequality in degrees Fahrenheit. So the first thing we need to do, we need to convert these to Fahrenheit. Okay, so there's an equation, Fahrenheit equals 9/5 Celsius plus 32. So we're just going to take these two numbers and we're going to plug them in here. So Fahrenheit equals 9/5 times -35 plus 32. And we're going to go ahead and solve that. So let's see, that's going to cancel with this and make that -7. So 9 times -7 is going to be -63 plus 32. I don't like the way that looks. Let's fix that. Okay, and then let's see, Fahrenheit is going to be what, -31? Okay, and then we're going to go over here and we're going to do the other side. So we're going to take Fahrenheit equals 9/5 times 125 plus 32. And we'll go ahead and cancel that. That'll go in there 25 times. And 25 times 9, that's going to be, what, 225? plus 32. So that's going to be 257 degrees. So my new equation, or my new inequality, is going to be negative 31 is less than f is less than 257. So there's my new inequality in degrees Fahrenheit. Okay. So I've got a little assignment for you. Have fun with that. I will see you guys later.